In this video, we're going to talk about finding probabilities using combinations. What is the probability of selecting a committee of 5 women and 4 men from a group of 9 distinct women and 8 distinct men? The structure of this type of a problem is as follows. We want to find the number of different ways we can select 5 women from 9 distinct women. So that's 9, choose 5. And the number of different ways we can choose 4 men from 8 distinct men. That's 8, choose 4. We need the probability for each combination, and we'll divide that, or rather we need the number of different ways for each combination, and we'll divide that by the total number of ways that we can select 9 people from 17 people. In other words, 17, choose 9. Now when we're working with combinations, the order in which objects are selected doesn't matter. And we have a special formula that we use for combinations. That formula is n factorial divided by n minus r factorial times r factorial. So for each of the combinations that we looked at on the previous page, we need to select, or we need to find the combination for each one using this formula. So for 9 choose 5, if we look at our formula, n factorial would become 9 factorial divided by 9 minus 5 factorial times 5 factorial. Since n represents the total number in our group, and 5 represents how many we're choosing out of that group. Now, a factorial can be represented as follows. For 9 factorial, we could write that as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. For 9 minus 5 factorial, that gives us 4 factorial, which can be written as 4 times 3 times 2 times 1. And then the 5 factorial, we would write as 5 times 4 times 3 times 2 times 1. From here we find there's quite a bit that we can cancel. Now you'll notice I included the 1's in my product, but the truth is we don't really need to include the times 1, since any number times 1 is simply itself. All of these factors cancel out. And if I look here, I see that 3 times 2 is 6, and that can cancel out with this 6. 4 divides into 8 2 times. So I'm left with 9 times 2 times 7 over 1. Multiplying 9 times 2 times 7 gives us 126. So I know that I have 126 different ways that I can choose 5 women from a group of 9 distinct women. Next, let's look at the number of different ways we can choose 4 men out of a group of 8 distinct men. So here we have 8 choose 4, that's 8 factorial, times 8 minus 4 factorial, times 4 factorial. That gives us 8 times 7 times 6 times 5 times 4 times 3 times 2. Here I'm not going to include times 1. As I explained earlier, its inclusion doesn't really make any difference. n minus r corresponds to 8 minus 4 factorial, so that's 4 times 3 times 2, times 4 factorial, which is 4 times 3 times 2. Now we cancel where we can, so we cancel out the 4 times 3 times 2 from the numerator and denominator. Here again, 2 times 3 equals 6. I can cancel that out with my 6 in the numerator. And 4 divides into 8 2 times. So now I'm left with 2 times 7 times 6. I'm sorry, times 5, not times 6. So 2 times 7 times 5, which equals 70. So now I know that there are 70 different ways I can choose 4 men from a group of 8 distinct men. Finally, I'll look at the number of different ways I can choose a group of 9 people from 17. So I have 17 factorial divided by 17 minus 9 factorial times 9 factorial. So that gives me our multiplication in the numerator So the product of these numbers divided by the product of 8 factorial times 9 factorial we cancel out our common factors. Here I can cancel 2 times 5 with the 10 in the numerator. 3 times 4 is 12. I can cancel these. 7 divides into 14 2 times. 8 divides into 16 2 times. So the product I'm left with is 17 times 2 times 15 times 2 times 13 times 11, all divided by 6, which is what's remaining in our denominator. Our result is 24,310. So we erase our 17, choose 9, write in the number of different ways this can occur, which is 24,310. And now we're ready to find the probability of selecting a committee of 5 women and 4 men from a group of 9 distinct women and 8 distinct men by taking the product of n choose 5 and 8 choose 4 and dividing it by 17 choose 9. The product in our numerator comes out to be 8,820 divided by 24,310. The quotient of these numbers becomes 0.3628. Converting this decimal to a percent, we could say that the probability of choosing a committee of 5 women and 4 men from a group of 9 distinct women and 8 distinct men is 36.28%. This concludes our example of finding probabilities using combinations. I hope you found it helpful, and we'll see you next time.